Like, subscribe, and hype the video. Also, leave a comment on any topics you want to hear about in the future. Okay, let's dive in. The universe is roughly 13.8 billion years old. It contains an estimated 2 trillion galaxies, each packed with hundreds of billions of stars. A significant percentage of those stars have planets orbiting them. A fraction of those planets sit in the right zone to support liquid water. And yet, despite all of that, despite the almost incomprehensible scale of time and space available for life to develop, spread, and make itself known, we have detected exactly 0 confirmed signals, 0 confirmed visits, and 0 confirmed evidence of any other intelligent civilization, anywhere, ever. That silence is not just strange. According to one of the most famous ideas in all of science, it might be the most important and most terrifying fact in the entire universe. Today, we're walking through the Fermi Paradox, the question that has genuinely haunted physicists, astronomers, and philosophers since the day it was first asked. We'll break down the math behind how likely alien life should actually be, and why the complete absence of any evidence for it is so deeply, profoundly unsettling when you really sit with the numbers. And in our next episode, we're getting into the actual proposed solutions to this paradox, some of which are far stranger and far more disturbing than most people have ever heard. Stick around for that one. But first, let's understand exactly what makes this question so hard to shake. The story of the Fermi Paradox begins in the summer of 1950 at Los Alamos National Laboratory in New Mexico, the same facility that had produced the atomic bomb just 5 years earlier. Physicist Enrico Fermi, one of the most brilliant and celebrated scientists of the 20th century, was having lunch with several colleagues when the conversation turned to a recent wave of UFO reports that had been making headlines across the United States. Fermi's colleagues were joking and speculating casually about the topic when Fermi, without warning, looked up and asked a question that cut straight through the humor. Where is everybody? It sounds almost too simple to be profound. But what Fermi meant, in the context of a conversation among people who understood the scale of the universe and the age of the cosmos, was something far deeper than a casual joke. Given the sheer age of the universe, and the enormous number of star systems that should have had billions of years head start on our own solar system, at least some of them should have produced intelligent civilizations long before us, and at least some of those civilizations should have had more than enough time to spread across the galaxy, or at minimum, make their existence detectable to anyone paying attention. So where were they? Nobody at that lunch table had a satisfying answer. And neither, 75 years later, does anyone else. Like, subscribe, and hype the video, because the deeper you go into this question, the more unsettling it gets. About a decade after Fermi's famous question, astronomer Frank Drake attempted to put some mathematical structure around the problem. In 1961, Drake developed what became known as the Drake equation, a formula designed to estimate the number of active, communicating intelligent civilizations that might currently exist in our own galaxy alone. The equation works by multiplying together a series of estimated factors: the rate at which new stars form in the Milky Way each year, the fraction of those stars that have planets orbiting them, the average number of planets per star that could potentially support life, the fraction of those potentially habitable planets where life actually develops, the fraction of life-bearing planets where that life eventually becomes intelligent, the fraction of intelligent civilizations that develop detectable technology, and finally, the average length of time such civilizations remain detectable before collapsing, going silent, or destroying themselves. The reason the Drake equation is so powerful and so maddening is that reasonable scientific estimates for the early variables in the equation, star formation rates, planet occurrence rates, habitability estimates, have gotten much more solid over the decades as our telescopes and instruments have improved enormously. But the later variables, particularly the fraction of planets where life develops, the fraction where it becomes intelligent, and especially the average lifespan of a detectable technological civilization, remain almost completely unknown, and estimates from different researchers vary by factors of billions. Depending on which estimates you plug in, the Drake equation can produce an answer ranging from tens of thousands of active civilizations in our galaxy right now, to a number so small it rounds down to essentially just us. Both answers use the same equation. That range tells you exactly how much we genuinely don't know. Let's focus on just how stacked the numbers seem to be in favor of alien life existing somewhere out there, because the scale of the argument is genuinely hard to fully absorb without walking through it directly. Our galaxy alone contains somewhere between 100 and 400 billion stars. Data from NASA's Kepler Space Telescope, which spent years specifically surveying a patch of the sky to count planets orbiting distant stars, produced estimates suggesting that on average, every star in our galaxy likely has at least one planet orbiting it. That gives us a minimum of roughly 100 billion planets in the Milky Way alone, and more recent estimates suggest the real number is likely significantly higher when smaller, harder-to-detect planets are included. Of those, a significant percentage orbit their stars in what astronomers call the habitable zone, the range of distances where liquid water could theoretically exist on a planet's surface, a condition widely considered one of the most basic prerequisites for life as we know it. Estimates for the number of potentially habitable planets in the Milky Way alone range from the tens of billions upward. And remember, this is just one galaxy. There are an estimated 2 trillion galaxies in the observable universe, each with their own hundreds of billions of stars and planets. The raw numbers, when you actually sit with them, make the complete absence of any confirmed sign of life anywhere seem almost statistically absurd. Like, subscribe and hype the video, because here's where the real puzzle begins. Here's the detail that takes the paradox from interesting puzzle to genuinely unsettling. Our solar system is roughly 4.6 billion years old. The universe is 13.8 billion years old. That means the cosmos had over 9 billion years to produce star systems, planets, and potentially life before Earth even existed. Some of those older star systems, if they developed intelligent technological life on timescales even loosely similar to Earth's, would have had civilizations with a head start of millions, or even billions of years ahead of us. In 9 billion years, even a civilization expanding at a tiny fraction of the speed of light could theoretically have crossed the entire diameter of the Milky Way multiple times over. Yet we see no evidence of any large-scale engineering in our galaxy. No megastructures, no artificial signals that have held up to scientific scrutiny, no probe that has ever unambiguously announced itself. No message in any of the frequencies we've been listening to for decades. The galaxy looks, to every instrument we've ever pointed at it, almost exactly as you'd expect it to look if we were alone in it. And that gap between the numbers that suggest life should be everywhere and the observations that show no sign of it anywhere is the Fermi Paradox in its most precise, most uncomfortable form. You might expect that as our technology improves and our ability to search for signs of life increases, the Fermi Paradox would start to resolve itself, that we'd eventually detect something and the question would answer itself. But in some ways, the opposite is happening. SETI researchers have now been actively scanning the sky for radio signals of potential artificial origin since the 1960s, using progressively more sensitive equipment covering more frequencies across larger portions of the sky than ever before. The James Webb Space Telescope has begun analyzing the atmospheric compositions of planets around other stars, searching for chemical signatures that might indicate biological processes. And the more we look, the more complete our silence appears to become. Every new exoplanet discovered in a habitable zone without any detectable signal narrows the range of comfortable explanations slightly. Every decade of improved scanning equipment that still produces no confirmed contact makes the question a little harder to simply wave away with, "We just haven't looked hard enough yet." The silence isn't proving aliens don't exist, but it is becoming increasingly loud. So here's where we land on the basic question. The math suggests intelligent life should, by virtually any reasonable estimate, have had more than enough time and opportunity to exist and make itself known somewhere in the observable universe. And yet, our best instruments, pointed at the sky for decades, have found nothing that holds up to scrutiny. No signals, no megastructures, no probes, no messages, just silence, across 2 trillion galaxies and 13.8 billion years of cosmic history. That silence doesn't prove we're alone, but it demands an explanation. And in our next episode, we're getting into every serious proposed solution to this paradox, including one called the Great Filter, which is arguably the most disturbing idea in the entire history of science when you really think through what it implies. Stick around for that one. Like, subscribe and hype the video so you don't miss part 2, and let me know in the comments what you think the answer to Fermi's question actually is. I'll see you in the next one.